then we should see the other configuration also.
That's true.
Because one more terminal is
One
pending.
more terminal is pending. Correct.
Yeah.
That is your common collector.
Collector.
Shall we look at that now?
Yeah.
Okay. So now what we need to do is we have the 3 terminals. Now you need to, collector is common, no? I'll make it like this, ground it nominally. And I have base and, this is your collector, base and emitter.
Where we will give input.
Well, the transistor is basically amplifying the current, no? So IC is beta times IB. So in some sense it is a current amplifier. So somehow it seems to me that that means that the base should be connected to the input signal and collector emitter should be the output.
Okay. Somehow the base emitter has to see the signal.
Correct. The base emitter has to see the signal somehow.
Only then the exponential.
Only then the exponential will
effect
come.
will be.
Correct.
Can be utilized.
Can be utilized. That's right. And then that will cause the collector current to be some large ratio with the base current and so on. That's right. Okay. So then we will give the input here.
Okay.
To the this thing.
Base.
So to the base. So I'll the input here. And now, okay, so the emitter has the output, no? Can I just connect a resistor here? Maybe RE. Something like this.
Yeah.
I can do that.
And output will be where we will take the output.
So we will just take the output. So this is the emitter, no?
Yeah.
We'll just take the output as a voltage here. No? Something like this is what I'm thinking. Actually, you don't even need RE. You can add a current source.
Correct.
If you want, right?
Correct.
In fact, we have seen this.
Correct.
Why don't we just add the current source?
Yeah.
Why do this, right? Just like we had emitter resistance there, we replace it by a current source. We can do the same thing here, right? And now that we have started adding biasing also, we need to do something about the collector, no? Because now I notice something. This is N, P, N, right? Now we need to make sure that this is correct.
Junction has to be
reverse biased, no? So somehow we need to ensure that.
Ground is not an option.
Ground is not an option. Correct. Okay. Because the minute you apply a signal here, it will get forward biased.
Correct.
We don't want that.
So that we will connect it to some
high voltage.
Yeah.
Yes. So then what we'll do, we will connect it to some high voltage. So maybe VCC, no?
Yeah. That's the highest we
That's
have.
That's the highest voltage we have. So now the collector is tied to VCC and we have a current source here. And this is your output, that's what we said. Input at the base. But now second problem. I remember what you pointed out when we did common base, no? You said that base emitter needs to be forward biased.
Correct.
We have the same problem here. We need to ensure that base emitter is forward biased somehow, because right now it's not forward biased.
Correct. So we have to again introduce resistive divider there.
We have to introduce again resistive divider. So this will make sure that there is some DC voltage, and now we can do this, no? We know we can couple the signal through the capacitor.
Yeah.
Now I'm sure the students understand this quite well. They have seen this like the third or fourth time.
Yes.
Right? And we also know the voltage here, the DC voltage here will basically, so if this voltage is VDC, no?
Yeah. In fact, top is connected to VCC.
Same VCC, correct. Right? So this voltage is VB.
Yes.
So this is the base voltage. Now the emitter voltage will be minus VB minus 0.7. 0.7 volts. This will be the DC value. We need to find out what the AC value is. Right?
Yeah.
But it looks like it is DC value is VB minus 0.7.
AC value also maybe it is similar
It should be similar. Well, let us see. So for
because
AC,
the base is at VI.
base is set at VI, correct? So this value, will it be stuck at VB minus 0.7? It cannot be just DC, no?
It cannot be DC,
DC,
but will it amplify? That's my doubt.
will it amplify? We need to look at that.
Hmm.
Shall we write down the exponential equations and check?
Hmm.
Okay, let's do that. So then what we'll do, we'll just write down the exponential relationship between current and voltage in the device, right?
Okay.
If you do that, well, let us see. Actually, maybe we don't need to write that even, right? Okay, I see what you're saying. So now for AC, the this current source is open circuited. Correct?
Yeah.
So let us do it like that. So I'll move this to the next page. Okay, so now I'll move this. So for AC, the current source is open circuited, no?
Yeah.
Which means there is no path for the current to flow.
Correct.
If there is no AC current through the device, VBE has to be constant. Correct? So if VBE is constant, that means VE has to follow VB.
Yeah, it's the same.
Perfect. So we'll write down the logic like this.
Yeah.
So let me write down the logic like this. So we will say that is constant. Correct? So which means if I naught is constant, clearly VBE has to be constant.
Yeah.
Right? Which means VE equal to which means this is VB minus VE is constant.
Yeah.
Right? So which means what we'll write it is and in fact the difference is 0.7.
Yeah.
Because it is the base emitter voltage.
Correct.
That constant has to be 0.7.
Yeah.
Correct? So then we can write this now. VB is basically R2 by R1 plus R2 times VCC plus VI minus VE is 0.7. So this tells us that VE is simply plus.
Yeah. In fact, we can forget the DC terms.
We can forget the DC terms. We are only interested in the AC.
Yeah.
Correct? So then we are interested in small VO.
Correct.
Right?
Yeah.
So we'll say we are interested only in small VO. So this side I get VE, no?
Yeah.
So this is already VE, right?
Correct.
Okay. So this basically has VDC plus small VE. So now VO is basically small VE, which is just VI actually.
Yes.
Oh, I see. So no amplification.
So it's a unity gain.
It's a unity gain, correct? Okay, I see. So this is a common collector amplifier.
Then what is the advantage?
There must be some, otherwise why would you, if it's unity gain, you might as well connect VI here, no?
Correct. But maybe I can drive a load.
You can drive a load, correct. because sometimes you may have a Thevenin resistance
Yeah.
for VI,
Yeah.
right? So very often you may see a case, maybe you have a very large Thevenin resistance,
Basically a source with high output impedance.
source with high output impedance.
If you draw some current, it will be very small
Correct.
output voltage.
That-
Yeah.
Correct. That's right.
Okay.
So then you need what is called a buffer,
Hmm.
or you can think of it as a VCVS, voltage control voltage source. And therefore now you can drive some load resistance RL. So this is your common collector amplifier. It is very useful.
Oh. So it just produces the input
Replica, correct.
as
So
the output.
that's right. So idea is that the input impedance of the amplifier is infinity.
Output impedance.
Output impedance should be 0.
Oh, so it's a very good source.
It's a very good source. Correct.
So it's a very good stage as an. I mean, if you want to drive the load, this is a very good.
This is a very good amplifying stage.
So earlier you were saying you can have multiple stages.
That is correct. If you have some resistive load to drive and the Thevenin impedance is very high, you would use this as the output stage of the amplifier cascade. Correct.
Or the other configurations were not so good as far as.
That's right. That's right. Actually, we have not looked at it explicitly, but you're absolutely right. I think common emitter we have. If you actually connect a load resistance here,
Yeah.
the gain will drop, no?
Correct.
It will get RC parallel RL.
Yes.
So the gain will drop.
Yeah.
Whereas this one, the gain will be constant even if you drive a load resistance.
So if we add this stage to the output of a common emitter also,
Correct.
common emitter, then we can use it for amplification.
Correct. This one you can, common collector, you can use for driving the load.
Okay, so this is a nice output stage.
This is a nice output stage, correct. So you can do something like this, as you are rightly pointing out. So you can do common emitter, common collector, and then drive a resistive load. Something like this.
Oh, excellent.
So this will give you gain, and this will give us your resistance, drive resistance.
Yeah. Very nice.
Nice. So these are all very commonly used circuits and cascades and so on.